Hello, this is Charlene. We're going to be solving quadratic equations by completing the square in this video. But the first thing I want to talk about is why. Why do we need to learn how to complete the square? Well, there are some quadratics and that is what this is. X squared minus 4x minus 3. It is an x squared term there. That means this is a quadratic equation. And typically, we learn to factor quadratic equations in order to solve them. But some quadratic equations in this format cannot be factored. So let's actually try to factor this one. So we've got this invisible 1 here in front. I'm going to multiply it times my constant and look for factor pairs of 3. So 1 times 3 equals 3. Are there any other factor pairs that equal 3? No, because 3 is a prime number. But let's go ahead and set it up. Let's go ahead and set it up as if we think that we can factor it, because technically, can I add or subtract a 1 and a 3 and get a 4? Well, yes, I can. So we're going to go ahead and try to factor it the way that we would normally factor a quadratic. Okay, so I've got the x squared. I'm going to take the square root of the x squared. It goes in the front, x and x. Then I'm going to take my factor pair that I've chosen, 1 and 3. And then in order to get a negative 4, I'm going to put negative 1 and negative 3. And that makes sense because negative 1 minus 3 does indeed equal negative 4. However, when I go to multiply this negative 1 times this negative 3, does that give me a negative 3? No. When I multiply a negative 1 times a negative 3, that gives me a positive 3. That is not negative 3. That means that this quadratic cannot be factored because these two factors are not the factors of this quadratic. So today we are going to go through the process of learning how to complete the square so that we can actually solve this quadratic and find out what the solutions are. Okay, so here we go. We have decided that this negative 3 is not working for us. So we're going to move it out of our way. We're going to add it to both sides of the equal sign because it is definitely not working for us. So we're going to rewrite it as x squared minus 4x. But since I'm completing the square, I'm going to do something a little extra. I'm going to leave a blank where that 3 used to be. But I still have equals 3 on the other side because I moved it to the other side by adding it to both sides. And if I add a plus blank to this side, guess what? I have to do the same thing to the other side. So I'm going to add a plus blank to this side. Now, what am I going to put in that blank? Well, I'm going to use what I like to refer to as the magic bullet. I'm going to put b over 2 squared in this space right here. Okay, so where do I get my b number? Well, I get my b number from the standard form of a quadratic. So anything that is in front of the x squared term is an a term, whatever is in front of the x term is a b number, and whatever is the constant by itself is the c. So I want to look for the b. Well, the b is in front of the x term. Well, in my original quadratic, the number is a negative 4. So that's what's going to go in my magic bullet. It's going to be negative 4 over 2 squared. So that is my magic bullet. Okay, so let's go ahead and move all this stuff out of the way. And there we go. Okay, well, the thing is, though, is that not only is that going to go in this blank, but it's also going to go over here. But let's go ahead and work it out. What is negative 4 over 2? Negative 4 over 2 is a negative 2, and negative 2 squared is negative 2 times negative 2. So it's actually plus 4. So I'm going to rewrite this one now. X squared minus 4x plus 4. and that is equal to 3 plus 4 on this side, which is 7. Okay, so I have now completed the square. This little section right here, this little trinomial that has been created, is a perfect square trinomial. And that is what is known as completing the square. Because now that this right here, x squared minus 4x plus 4, is a perfect square trinomial, that means that I can factor it according to a pattern. So what is the pattern for factoring it? Well, it's going to be x, that's the square root of x squared, and the square root of the 4. So x, and I'm going to take this sign, so x minus the square root of 4, which is 2, close my parentheses, and square it. And that is equal to 7. So now that we have completed the square, like I said, this piece right here, this is a perfect square trinomial. That is where we completed the square. But now that we have factored it according to the pattern, we can now use the square root method to finish solving for this. We're going to use the square root method. Well, what is that? We're going to take the square root of both sides. Let me scoot all this over just a little bit so I've got a little bit more room, because anytime you take the square root of both sides, you are going to put a plus or minus in front of your answer side. So plus or minus square root of 7. So now this square root is going to cancel out the square. I'm left with x minus 2 is equal to plus or minus square root of 7. And now I'm going to add 2 to both sides. So plus 2 and plus 2. So where does that leave me? Let me get that out of my way. That is going to give me, because those 2's are going to cancel out, and that leaves me with x is equal to 2 plus or minus radical 7. So this produces the 2 solutions for my original quadratic, completing the square. It gives you options. Let's look at the next one. Okay, so this one, they've given us x squared plus 4x equals 77. Well, the first thing you want to do is always just make sure that it is in standard form. So you have ax plus bx plus c is equal to 0. So you want to move everything. You'll move that 77 to the other side. So let's go ahead and rewrite that as x squared plus 4x minus 77. So I'm going to subtract 77 from both sides. Now, technically, there is an equal 0 on the end, but it's just in my way if I'm trying to solve it. So we're going to leave it off. But let's check and see if we can factor it first. So again, we have an invisible 1 multiplied times the 77 gives me 77. Factor pairs of 77. 1 times 77. 2 doesn't fit. 3, 4, okay, so 7 fits, 7 times 11. Okay, so we want to ask ourselves, can I add or subtract 1 and 77 and get a 4? No. Can I add or subtract 7 and 11 and get a 4? Well, yes, I can. So we're going to try to factor this one. So we're going to take the square root of x squared, and that's going to go in the front. That's going to go in the front of my parentheses. And then I'm going to take my chosen factor pair of 7 and 11, put it in the back, 7 and 11. In order to get a plus 4, I would need a plus 11 minus 7. And if I multiply negative 7 times a positive 11, does that give me negative 77? Yes. So in this case, I'm going to be perfectly honest with you. If I can factor it, I'm not going to go to all the trouble to complete the square. Now, can you? Can you complete the square on this one? Yes, you can. But at this point, those are my factors. And now all I have to do is do the zero product rule. Zero product rule. Product rule. which means that I am going to say x minus 7 equals 0 and x plus 11 equals 0. And then that is going to give me my solutions. If I work that out. So my solutions are going to be plus 7, cancel. X is equal to 7, and minus 11, cancel. And then x is equal to negative 11. So those are my solutions of this quadratic. It can be factored. And what are some other names for the solutions? We can call those solutions x-intercepts. We can call them zeros because the y value, which is the function value, will always be 0 on those x-intercepts. And we can also call them roots. So all of these words are kind of interchangeable for the solutions or the answers to our original quadratic. Okay, but I would check for it first and see if you can factor it, and go ahead and factor it if you can. Otherwise, you may want to use the option of completing the square. Okay, our next problem is x squared minus 6x is equal to negative 4. And again, we need to make sure it is in standard form. So that means I'm going to move that negative 4 to the other side. I'm going to add it to both sides. So I'll do plus 4 and plus 4 and rewrite it as x squared minus 6x plus 4. Okay, so again, just briefly, we're going to check and see, can we factor it? So 1 times 4 gives me 4. Factor pairs of 4 is 1 times 4. And 2 times 2, are there any other factor pairs? No. Can I add or subtract 1 and 4 and get a 6? No. Can I add or subtract 2 and 2 and get a 6? No. So I have no factors that will work at all. So therefore, I cannot factor this quadratic. So we are going to complete the square. Okay, so what are we going to do? We have decided that this 4 is not working for us. So we are going to move it to the other side. We're going to move it away. So I'm going to do minus 4 and minus 4. But if we're completing the square, I'm going to add a plus blank there in place of where the 4 used to be. So x squared minus 6x plus blank is equal to negative 4. And if I add plus blank to one side, I still have to add plus blank to the other side. And what am I going to put into there? That blank space, I'm going to put the magic bullet for completing the square. B over 2 squared. And where do I find that B? I find it in front of the x term, and the number that is in front of the x term is the negative 6. So that means my magic bullet is going to be negative 6 divided by the 2 and squared. Okay, so over here, I'm just going to go ahead and work it out. What is negative 6 divided by 2? Negative 6 divided by 2 is negative 3, and negative 3 squared is negative 3 times negative 3, which is 9. Okay, so let me rewrite it one more time. It's going to be x squared minus 6x plus 9 is equal to 9 minus the 4 is going to leave me 5 on the other side of the equal sign. So this right here, that is a perfect square trinomial. That means that I have completed the square right there. I completed the square by changing that piece to a perfect square trinomial. Okay, once it is a perfect square trinomial, that means I can factor it according to a pattern. So I'm going to take the square root of x squared and the square root of 9. I'm going to put the square root of the x squared in the front. I'm going to put the square root of the 9 in the back. That's 3. I'm going to bring this negative sign down, that minus sign, and then I'm going to square it. And then that's still going to be equal to my 5 that's up here. So now that it is in this format, I can now use the square root method to finish solving it. So that means I'm going to take the square root of this side, and I'm going to do plus or minus on the answer side, plus or minus the square root of 5. And so that is going to leave me with x minus 3 on that side because the square root cancels out the square. And that's going to be equal to plus or minus square root of 5. Now I am going to add 3 to both sides. Plus 3 and plus 3. These 3's will cancel out. And that is going to leave me with x is equal to 3 plus or minus the square root of 5. So we have a plus answer, we have a negative answer, and those are my two solutions for my original quadratic that I started with. Okay, our next problem says x squared minus 6x minus 41 equals 0. So it is already in standard form where everything is on one side and the 0 is on the other side. So we just need to double check. But there's also a clue that before we try to factor it and confirm that it can't be factored, there's something that we can just recognize about this that would help us know if it can be factored. And that's the fact that 41 just happens to be a prime number. So if you recognize that this third number, the constant in our quadratic, is a prime number, that automatically clues you in because the only factors of 41 will be 1 times 41. And indeed, you cannot add or subtract 1 to 41 and get a 6. So we can definitely just decide to go ahead and complete the square on this one. So this 41, it's a prime number. It's not going to work for us. So we are going to add that 41 to both sides in order to get it out of our way. Okay, so we're going to rewrite this as x squared minus 6x plus blank, because that is part of our completing the square process, and that's going to be equal to 41 plus blank on the other side. And we're going to put b over 2 squared. Our b is going to be negative 6, so that means in the blank I'm going to put negative 6 divided by 2 all squared. And when I work it out, my negative 6 divided by 2 is negative 3. Negative 3 squared is going to give me a positive 9. And that means that I can rewrite this as x squared minus 6x plus 9 is equal to 50. Okay, and like we said before, this piece right here is a perfect square trinomial, and that means that we have completed the square. So we've done that process now. Now that we have turned this into a perfect square trinomial, that means I can factor it according to a pattern. So the square root of x squared goes in the front, the square root of 9 goes in the back, and the sign that's in the middle comes down, and then I square that. Okay, and that's going to be equal to 50. Now that it's in this format, we are allowed to use the square root method to finish solving it. So I'm going to take the square root of both sides, square root of 50, but on the answer side, I need to make sure and put plus or minus. So the square root is going to cancel out the square. I end up with x minus 3 is equal to plus or minus radical 50. Now I'm going to add 3 to both sides. Add 3, add 3. Those will cancel. And that is going to give me my solutions. X is equal to 3 plus or minus the square root of 50. Now, can we actually break down 50? Should we simplify this further? Well, let's check and see. If I have the square root of 50, I can break that down into 5 times 10, which also breaks down again into 5 times 2. Well, there are a pair of factors. This pair of 5s is a perfect square. That means I can pull one 5 out to represent the 5, but the loosey-goosey 2 is going to have to stay in the house. So that means that the square root of the 50 is ultimately going to be equal to 5 radical 2. And so I can simplify this just a little bit further, say that my solutions to this quadratic are equal to x is equal to 3 plus or minus 5 radical 2. So that provides me two solutions, and two solutions is what I'm usually looking for a quadratic. So we have solved this quadratic. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.